Alright boys, let's look at the homework here in complex numbers. Okay, so the first thing this says here, the complex number z1 is equal to a plus bi, where I squared is equal to minus 1, is shown on the Aragon diagram below. So the first thing we have to do here, boys, is draw this Aragon diagram here. Just let me explain it to you. Alright. Okay, so again you have your imaginary and your real axes. Okay, so we have 1, 2, 3 and 4. And 1 and 2, is it? No, just out far as 1. Okay, we'll go down as far as minus 2. And up as far as 2. Not too bad. Okay, there we go. Alright, and they have z1. Okay, if we were to write that as a complex number, okay, that would be 3 plus 1i. Okay, so for the first part of question 6a, alright, they want what a and b is, right? Because they're saying z1 is equal to a plus bi, but we know z1 is equal to 3 plus 1i, therefore a is equal to 3 because they match, okay, and b is equal to 1 because they match. Alright, part 2. Leave it red actually. Okay, part 2 says the image of z1 under reflection in the real axis is z2. This is c plus di, and they want the values of c and d. Okay, well if it's an image to the real axis, it means it hits the real axis and goes exactly the same distance beyond it. Okay, so we'll be there. Alright, and that's z2. And the reason why I know it's there is because it goes the exact same distance down through it. And look at this here, it's actually 3 minus 1i this time. So you can see there, the signs just change. So you can argue it's the conjugate. Okay, so we have c, z2 is equal to c plus di. Okay, we know z2 now is 3 minus 1i. So we know c is equal to 3 and d is equal to minus 1. Okay, now part B is a little bit trickier than this, lads. Okay, so let's read this carefully. It says the angle theta is formed by joining z1 to 0, 0i. Well, that there, lads, is 0, 0i. Okay, so let's draw that. Use a different color. So okay, so z1 to 0, 0i, and then 0, 0i out to z2. And we're saying in here then that angle is theta. Okay, now I'll make this as easy as possibly can. If you see here, lads, if I was to draw that line continuous there, what I'm going to do is I'm going to create 2 equal right angle triangles. Okay, we know the distance here from z1 down to the real axis is 1, and likewise real axis down to z2 is also 1. We know from 0, 0i all the way out to this point here. So if I get this here, I'll show you. So from this point out to where it's there, okay, we know that distance there is 3 because it goes from 0 out as far as 3 on the real axis. So I can pencil in that there for 3. So if I take one of those right angle triangles down here, okay, that's 1, and that's 3, and that's half of theta, okay, because we're only half in it. Okay, if you remember, excuse me, from your junior cert days with right angle triangles, it's so, okay, now I realise we haven't done this yet this year. Okay, we will be doing them next year. But if you look at here, that there is the opposite, and that there is the adjacent. Okay, so you need to use tan, because that is the O and A stands for opposite and adjacent. So I come over here to B, okay, and I write, well, the tan of half theta is equal to the opposite over the adjacent. So the tan of half theta is equal to the opposite, which is 1, over the adjacent, which is 3. Okay, well, half theta then is equal to tan inverse of 1 over 3. Okay, so half theta. Okay, so the tan inverse, okay, of 1 over 3 is 18.4349. Okay, so 18.4349. No, I don't want half theta, I want theta. Okay, so theta, you multiply both sides by 2. Okay, and that gives you 36.87 if you round off to 2 decimal places. Okay, now be careful. The question that asks for theta, they wanted what cos theta is. Okay, so they want what cos theta is. Okay, well, cos theta would be the cos of 36.87. Okay, so cos bracket 36.87, okay, is equal to 0.799999, so we can say 0.8. Okay, that's the answer to that question. Alright, now I know that was tricky, lads. That was B part 1. Okay, but don't worry, we'll be covering this stuff next year. Okay, B part 2 then. Okay, let's show that the mod of Z1 times the mod of Z2 times cos theta, which we know what it is now, is equal to AC plus BD. And AC and B and D we got from the earlier parts in part A. Okay, well the mod of Z1, so if we go back up, if we come over here actually, okay, we know Z1 was 3 plus 1i. Okay, so to get the mod of that is 3 to be squared plus 1 to be squared is equal to root 10. Okay, and Z2, okay, we know is 3 minus 1i. So the mod of that again is 3 to be squared plus minus 1 to be squared, which is again root 10. Okay, well Z1 is root 10 times Z2, which is root 10, times cos theta, which is 0.8, is equal to A. We know that A is 3. We know that C is minus 1. Okay, where am I getting those from? Okay, getting them from up here. So A, B, C, and D. See them here? A, B, C, D. So that's actually incorrect there. I'll rub that out and do it again. Okay, so it's A is 3 and C is also 3. Okay, B is 1 and D is minus 1. Alright. Now root 10 by root 10 is 10. Okay. And bright point 8 is 8. And 3 by 3 is 9, minus 1 is 8. So therefore you've shown it. Okay. So that was that question, boys. So then I gave you one more question, which is a little bit easier than that question. Okay, and this was 2014, I believe. Okay, and it said let Z1 be 5 minus I. So Z1 is 5 minus I. And Z2 is equal to 4 plus 3i. And of course it says I squared is equal to minus 1. Now, A part I. Okay, it says find Z1 minus Z2. Okay, well that would be 5 minus I minus, don't forget, bracket 4 plus 3i, because that minus will change the signs. So 5 minus I minus 4 minus 3i. Okay, 5 minus 4 is 1, minus I minus 3i is minus 4i. Okay, real with real, imaginary with imaginary. Okay, part 2. Okay, it says verify that the mod of Z1 minus Z2, okay, is equal to Z2 minus Z1. Oh, we just got Z1 minus Z2 above here. That's Z1 minus Z2, worked out to be that. Okay, so that can be 1 minus 4i. Now Z2 is 4 plus 3i minus bracket Z1, which is 5 minus I. Okay, we'll leave that as so for the time being. So it's going to be 4 plus 3i minus 5 plus I. Okay, again, leave it for a sec. We'll tidy this up now. 4 minus 5 is minus 1, and 3i plus I is 4i. Now let's get the mod of each. 1 to be squared plus minus 4 to be squared is equal to minus 1 to be squared plus 4 to be squared. 1 to be squared is 1, minus 4 to be squared is 16. Minus 1 to be squared is 1, and 4 to be squared is 16. So root 17 is equal to root 17, therefore verified. Okay. Now, the next question says is, give a reason why the mod of z minus w will always be equal to w minus z. Okay. Your simple reason is the absolute values of the real and imaginary parts are the same. Therefore, the mod will always be the same. Okay. I'll post that up on your Edmodo anyhow. Okay. Okay, moving on to the final section, lads, which you've seen this over and over again before. I'll just do it over this side here. Okay, it's saying that Z3, okay, find Z3, should I say, such that Z1 is equal to Z2 over Z3. Okay? Now, you want to find Z3 here, and you want to give your answer in complex form number, alright? Now we want to find Z3. Okay, so the best thing to do, lads, is rearrange this here. So you have Z3, the subject of the equation. So if I was to cross multiply, okay, you have Z2, okay, is equal to Z1 times Z3. I want Z3 on its own, so I'm going to divide both sides by Z1. They cancel, so you're left with Z3 is equal to Z2 over Z1. Okay? Probably run out of space here, but however, I'll move on to the next page. So Z3 is equal to Z2. Now we know what Z2 is. Okay, Z2 is 4 plus 3i. So 4 plus 3i. Okay, and we want to put that over Z1. I'll get Z1 here. Come on, Z1 is 5 minus I. Okay, as we've seen many times before, lads, multiply above and below the line by the conjugate of the denominator. In this case, it's just changing the imaginary sign. We multiply these out, lads, and we tie it up till we get a complex number. Okay, so Z3 will be equal to 4 by 5, which is 20. 4 by I, which is 4i. 3 by that's 15i plus 3i squared. Over 5 by 5 is 25 plus 5i minus 5i minus I squared. Alright. Tie up the top line, we're going to have 20 plus 19i plus 3 times minus 1. Okay, over 25, they cancel, minus I squared, sorry, which is minus 1. So Z is equal to 20 minus 3 is 17 plus 19i divided by 26. So Z3 is equal to 17 over 26 plus 19 over 26i. Alright? And there you have A so is equal to 17 over 26 and B is equal to 19 over 26. Alright, there you go, boys.